All right, so guys, sorry for not being able to be in the live session today, but I did want to just take this opportunity to just do a screen capture of what, kind of just review what we started working on before the Thanksgiving break, just to give a bit of just a review and also go and do a few other examples. So I'm gonna go through these examples since we've already kind of discussed them, and we're just reviewing some of these concepts. I do want to go over these very quickly. All right, so guys, pay attention, and towards the end of this video, we will be doing a few more examples that we haven't covered, we haven't touched before. So let's look at so guys, last time we were talking about units of measures and measures of accuracy and precision. So that's what we're going to be talking about right now. So let's go over a few examples. Which measure units would best use to measure would be best used to measure the Empire State Building? So guys, we have some different choices. So always eliminate the ones that are obvious. You know, like centimeters and inches. You definitely want to measure the Empire State Building in centimeters and inches. And miles seem maybe a little too long, so we're going too overboard. So we're left with between meters and feet. So actually, both of those measures of units are decent measures of unit, are good measures of units to use to measure the Empire State Building. However, I believe meters will be slightly better because the Empire State Building is so large, so huge that it would definitely benefit to use meters instead of feet. However, feet is not a bad unit of measure to use, but the question asks what will be the best. All right, and some people wouldn't think meters because we typically don't use meters in the United States, but that definitely would be the better measure of unit to use. All right, so the number two. So we have this pool. So which would be the best measure of units to use to measure the amount of water that is in a pool? So we have cups, gallons, ounces, pints, and quarts. So this one actually is a little bit more obvious to most students. So of course we use gallons, all right, because cups are too small. Even pints and quarts are too small and certainly ounces are way too small. So gallons would be the best choice in answer choices. Number four says, what would be the best, which measuring units would be best used to measure the distance between the Earth and the Moon? All right, so of course, inches is way too small. Even yards, meters, and certainly feet will be too small of units to use to really measure. I mean, you could, but the best measure of units to use will be kilometers, right? Kilometers. All right, so which measure units would be best used to measure the length of a door? So we have miles. Of course, miles is way too long. Kilometers, same thing as miles. Then you have meters. Meters is not terrible, but still not great. Inches and feet. So both of those are really acceptable, but which one would be best to use? So I would say inches in this case. It's actually better to measure the doorway in inches. All right. So I'll move forward. So this is one where we had a bit of a discussion in class. So what would be the best unit of measure to measure the amount of time it takes to bake a cake? All right. So of course we wouldn't measure in seconds, months, and years. So that's obvious. So there was a discussion about hours and minutes, because some cakes take longer to bake than others. However, typically, most cakes take around 35 to 45 minutes to bake. Even if you had a cake that required a little bit more time, it typically wouldn't be too much more than 45 minutes. I mean, of course, I'm not a baker, but it wouldn't go further than 45 minutes or much further than 45 minutes. So I wouldn't definitely use hours to measure the amount of time it takes to bake a cake. So I would definitely use minutes. All right. Then we also talk about accuracy and precision. So accuracy is how close is to an actual value. So say if let's go back to the door. So say if I measure a door to be, I don't know, 11.5 feet high. All right, the closer the measurement is to 11.5, the more accurate it is. To where precision is, what if you take a bunch of different measurements? Precision is how close all the measurements are to each other. All right, so if you take a bunch of different measurements, is how close all of the measurements are to each other. It doesn't necessarily have to be close to the actual measurement, but it's how much it is close to each other, to all the other measurements. So that's the difference. So something can be precise and not accurate, and some can be accurate and not precise. And some can be both precise and accurate, and some can be both neither accurate nor precise. So for example, precision. So say if this red circle right here was your actual value, and you had a whole bunch of dots over here. So these dots would not be very accurate because it's pretty far from the actual value. However, someone may say, hey, they're very precise since they're very close to each other. All right, so these green dots are precise but not very accurate. All right, right here, say if we have these bullseye and we have the darts. So right here, this one would be high accuracy but low precision because the darts are they're close to the bullseye but kind of far away from each other. They're kind of spread out. In this one, it will be high precision but low accuracy. All right, it's low accuracy because it's not really close to the bullseye, but they are very precise because they are the measurements or the actual place that they're hitting are relatively close to each other. They're bunched together. So high precision, low accuracy. And this one is high precision and high accuracy. All right, because all the darts are very close to each other, but and they're also really close to the bullseye. So in this example right here, we have football. The kicker of this football team, he keeps kicking the ball and he keeps hitting the right goalpost. All right, so he's very precise, right? Because he's keep hitting the exact same area, so he's precise with the area that he's kicking the ball to. However, he's not very accurate because he's not actually getting the ball in the goalpost. So he's precise but not very accurate. All right, and guys, and these are just trying to get you to understand the concepts. So then when we actually get to the math part, it would make more sense on what to do. So right here it says, which of the following shows high precision but low accuracy? So high precision means that so all the darts will be close to each other. Low accuracy means it won't be necessarily near the bullseye. So that right here, B is the correct answer. All right here it says, which of the following shows low accuracy and low precision? So low accuracy means it will not be near the bullseye, and low precision will be they're not near each other. So that will be C. All right, it will be C. Right here, so you have this soccer player who's trying to kick the soccer ball into the net. So it's asking which one shows low precision but high accuracy. So low precision means they're not necessarily kicking in the same area, but they are kicking the ball into the net. So right here it will be D. All right, because as you can see, they're kicking the ball into the net, but they're not bunched together like on A and C. So D would be high accuracy but low precision. All right, guys. So let's just apply those concepts to some real world math problems, guys. And I've worked these out already onto the screen. So, guys, just pay attention. So right here it says James took 4 measurements of a building below. The actual height of the building is 500 feet. Which of the following measurements is the least precise? So, guys, anytime you want to find out what is the most or least precise, you need to find. So, guys, here are all the measurements. So he took 4 measurements, and here are all the measurements. So in order to find the least precise, you need to find the average of all 4 measurements. You need to take the average of all 4 measurements. So, guys, just as a review, in order to find average, you need to add them all up, add up all the numbers, and then divide by the number of numbers you have. So in this case, we're going to add up all these numbers, A, B, C, and D, and then we're going to divide by 4. So once we do that, we find out that our average is 495 and 495 and 3/10. 495 and 3/10. So then what we're gonna do, we're gonna take with this what we're gonna do with the average is we're gonna take each answer choice and we're gonna subtract the average from each answer choice. So subtract the average from each answer choice. All right, and once we do that, we're gonna get our answers right here. So right here we have negative 1.4. And guys, the negative is irrelevant, right? Whether it's negative and positive is irrelevant. So we're going to kind of like take the absolute value. But not to get you confused with that. It's just the negative, or whether it's negative or positive, that's irrelevant. We just want to see what number is furthest from the average. So we're subtracting each number from the average to get these numbers. So we get 1.4, 1.1, 1.8, and 4.2. Well, guys, 4.2 definitely is a larger number, so that means it's the furthest from the average. So, guys, this D is the least accurate. D is the least precise. D is the least precise when it comes to these measurements. All right. So D is the answer. Now, if you wanted to, now say if we had a question, because you could be asked this question too: what is the most precise? What is the most precise? So in this case, B will be the most precise because the difference between the mean, the average, and your measurement is 1.1. So that is the closest to the average. So that will be the most precise. And guys, you also may see some questions that say, hey, which one is more accurate? So guys, when we talk about accuracy, is what number is closest to the actual value, right? What is accurate, right? If something's accurate, that means it's close to the actual value. So guys, then you would just subtract each value from the actual value. So you will subtract this from this, this from this, and this from this, and this from this. So you will pick the one. So if you're trying to find which one is the least accurate, it will be the number that's the furthest from 500. Right? The number that's furthest from 500 will be C. So guys, this will be the least accurate. All right, and the most accurate the most accurate will actually be D. D will be the most accurate. So if you understand, D is the least precise, but D is the most accurate. Right? D will be the least precise, but D will also be the most accurate. So hopefully that makes sense. So guys, just remember, accuracy is the closest it is to the actual value. The actual value is 500. So of course this will be the most accurate. However, it didn't ask what will be the most accurate. It asks what will be the least precise. So guys, so someone took four different measurements. So all of these measurements, so these three measurements are very close to each other. But this measurement is actually furthest from the other three. So that's the reason why it's the least precise one. However, it is still more accurate. All right. Let's move on. So right here it says a rectangular door has a measurement length of 11.32 feet and a width of 5.14 feet. What is the least precise measurement of the perimeter of the door? So guys, so right here, remember when we talk about precision is the measurement that's furthest away from the other measurements. So you will have to find the average of all four measurements. All right, so remember we're going to add them up, divide by 4. And so our average right here is 32.84. That's our average, 32.84. So now we need to find a difference. We need to subtract each measurement from the average. So we're going to subtract each measurement from the average. And we get 0.14, 0.08, 0.04, and 0.26. So the least precise measurement will be the one that's furthest from the average. Well, the measurement that's furthest from the average will be D because it's 0.26. Right? And then the rest are closer. So our answer would be D. Guys, take a look, maybe pause the video and take a look at some of just some additional explanations of when we talk about accuracy and just to understand that as well. All right, so example 6 says, which of the following measurement is more precise? All right, so the measurement 4 millimeters is more precise because it measured with the instrument at the minimum least count. So guys, if you think about all these units of measures, we have meters, centimeters, and millimeters. So if something is measured down to the millimeters, that means it's typically going to be more precise than something that's measured to the meter, right? So millimeters would be more precise because it's a smaller unit of measure. That means you can get really, really, really close to that exact measurement. All right, we're almost finished. We've got about 3 more slides. So right here it says which measurement is most precise. All right, so guys, if you notice all these 4 measurements, they're in different units. So guys, we cannot do any math or we can't make any comparison until we have all of our units into the same units. Now you can either convert meters into millimeters or you can convert these 2 millimeters into meters. It doesn't matter, right? So all the units can either be meters or millimeters. So I decided to convert the meters. So C and D are in meters. So I decided to convert these 2 into millimeters. So all of the measurements, the units of measures are the same. So now that all A, B, C, and D are now in the same units of measure, so now we can find the average. So we do basically what we did in the previous example. So we're trying to see which one is most precise. We find the average of all 4. So we add up A, B, C, and D, and we get 771.6. All right. Then afterwards, so right here, let's look at our notes. So it says get all the measurements of the same units, then find the average, which we did right here. Afterwards, find the difference of each measurement with the average to find the measurement that is closest to the average. So guys, if you were to subtract, so this is what we did down here for A, B, C, and D. These are just the values after you have subtracted each answer choice from the average from each answer choice. So 762.4 minus 771.6 is equal to 9.2. All right. So 762 minus 771.6 is 9.6. And C is the exact same thing. 762 minus 771.6, which is 9.6. And then 800 minus 771.6 is 28.4. So guys, the most precise will be the closest to the average. So A is the closest to the average, is the smallest number. So that means it's the closest. So our answer is A. A is the most precise. Now, if the question asks what is the least precise, we know it will be D, because it's the furthest away from the average. All right, so and basically we just answered the problem, the next slide, right? So it says stop. From the previous example, what is the least precise measurement? All right, so remember, here's our differences between the measurements and the average. So our least precise will be D because it's the furthest away from the average. All right, and last but not least, I do want to go over this type of problem. So, guys, we're introducing ranges. All right. Sometimes when you measure, or say if you're running a machine and a machine job is to measure certain things. Sometimes when a machine measures things, there's a certain error percentage with each measurement. All right, there's some type of level of error. Sometimes it's not always 100% precise on the dot or accurate on the dot type measurement. So in this example, a drink dispenser dispenses approximately 590 milliliters of soda, that should be soda, into a bottle. The amount dispensed into each bottle can be in the range of plus or minus 1% of 590 milliliters. All right. So plus or minus 1%. What will be the range of soda dispensed in each bottle? So guys, the percentage of error could be 1%. So that means it could be 1% above and 1% below 590. All right, that's what that plus or minus means. It can be 1% above or 1% below. So guys, I have all the steps right here in red, and then I worked it out on the side. So first step is, first of all, we need to find out what is 1% of 590. What is 1% of 590, guys? And if you remember, in order to find 1% of anything, you had to convert 1% into a decimal. So 1% as a decimal is 0.01. So you're going to multiply 590 times 0.01, and we get 5.9. 5.9 milliliters. So step 2, remember, is plus 1% and minus 1%. So step 2, we're going to subtract. That's going to be the minus 1%. So we know 1% is 5.9. So we're going to subtract 5.9 from 590. And once we do that, we get 5 584.1. 584.1. All right. And then step 3, it says add. Now step 3 is, hey, we're going to add the answer from step 1 to 590. So basically that 5.9 value we got from step 1, we're going to add it to 590. So 590 plus 5.9 is equal to 595.9. So guys, the range that the soda will be dispensing to each bottle will be between 584.1. Ooh, I forgot to finish this. 584.1 milliliters to 595.9 milliliters. So guys, that's the range. So that means it can fall. That means it's not going to go any lower than 584.1, and it's not going to go any higher than 595.9. So it's going to be somewhere in between that range. All right, guys. So hopefully you guys understood this. You can always go back and watch it, rewind it, and if you need to rewatch it again. Thank you. Y'all have hopefully you guys enjoy your Thanksgiving break, and thank you for watching this video. See you later.